configure, how we can configure router ID, how router ID is selected with one of this first method. First, maybe administrator configures the router ID with MPLS LDP router ID, and after that interface name. Maybe an administrator wants to configure itself the MPLS LDP router ID. MPLS LDP router ID is a 32-bit identifier, 32 bits identifier, and can be chosen from an interface IP address. Okay, it's only unique identifier. Or if administrator doesn't configure the router ID, the router ID is chosen from the IP address of first loopback interface. If we don't have loopback interface on the router, it has chosen from the IP address of physical interfaces. The second method is highest IP address of loopback interfaces, that is up. Okay, it should be up. And if we don't have loopback, highest IP address of non-loopback interfaces. Okay, should be up. Now, we didn't configure the router ID, and we didn't have loopback interface. Because of that, the highest IP address of non-loopback interface now chosen for router ID. Let's check it. In R2, what is the highest IP address? R2 has two interfaces. One interface is 10.1.2, one interface's IP address is 10.1.2.2 and other 10.2.3.2. Because of that, 10.2.3.2 is higher and selected as the router ID. Again, if we enable MPLS IP, we are enabling MPLS IP in the link between R2 and also R, for example, 3, and I want to use my configured router ID between them in R3, for example. In R3, I want to use this router ID. I can configure a loopback 0 as 3333/32. Okay, I want to check the router ID of R3 after this configuration. In R3, first en conft interface loopback 0 IP address quad 3 quad 255. I enable it on OSPF, router OSPF1, router OSPF1 network 3333 quad 0 area 0. Okay, now I want to configure on R2 MPLS en conft, okay, interface Ethernet 01 MPLS IP, and again in R3 interface Ethernet 00 MPLS IP. Look at here, the neighborship between R2 and R3 now occurred, okay, or established. In R2, I want to check show MPLS LDP neighbor. Okay, you can see that R2 has two neighborship. First, with R1, 10.1.2.1, it's the router ID of the R1, and quad 3, this is the router ID of R3. Why R3 choose its router ID as quad 3? Because loopback interface is preferred to physical interface. This is the first example. And we can go to the R4. In R4, I want to configure two loopback interface. Look at here, loopback 0 and loopback 1. The IP address of loopback 1 is 4445/32, and the IP address of loopback 0 is, for example, quad 4/32. Let's configure it. Look at here. First, in R4, I want to configure two loopback en conft then interface loopback 0 with IP address of quad 4, quad 255.255.255, and then interface loopback 1 IP address 444.5. Okay, router OSPF1 network quad 4, quad 0, area 0, and then network 44445 quad 0, area 0. Okay, now I want to enable MPLS in the link between R3 and R4 here and then here. Okay, let's go to R3. In R3, interface ETH01 MPLS IP, and also in R4 interface ETH00 MPLS IP. Now we should have a neighborship, yes. In R3, I want to check the peer identifier, show MPLS LDP neighbor. Look at here, the first neighbor is 10232, that is R2, and the second is 4445, that is R4. Why? Because the IP address of loopback 1 is higher than the IP address of loopback 0. Maybe it's okay, but maybe you want to change it. For example, I want to use the loopback 0 IP address, okay? Because of that, I should choose the other router ID. MPLS LDP router ID, loopback MPLS LDP router ID, and then I should use loopback, for example, 0. Okay, let's check it. In R3, is any change occurs? Look at here. No change. Why? Because the router ID now is chosen, and no change does occur until they're restarting the router or disabling MPLS, again enabling MPLS. But you can use this command, MPLS LDP router ID loopback 0, and use force. If you use force, forcibly change the LDP router ID in this time. I use force. You can see the router, the neighborship goes to down state, and again the neighborship now is in the up state, and now we can change the router ID of R4. For example, show MPLS LDP identifier. You can see that the router ID of neighbor changed to the quad 4. It's the usage of MPLS LDP router ID command. And now you know this command, MPLS LDP router ID interface name with option of force. Very good. Let's go to the first topic, LDP identifier. As I said before, LDP identifier has two parts. One part is the router ID or LDP router ID, and the second is the label space. You know that because we are only using per platform label space. Because of that, we every time see this label space 0 in all of the peer neighborship. For example, if in R1, checking again the result of show, let's check in R2 or maybe in R1. Okay, again a few seconds later we can check it, and also we can go to the, yes, it's okay, check it, show MPLS LDP neighbor. Look at here, peer LDP identifier is 10232, that is LDP router ID of the neighbor, and colon 0 is the label space that the labels of this router given to us. But don't forget, in our scenarios, every time we use only per platform label space. Because of that, every time it's 0, and only important things this LDP router ID. Okay, and also if you check show MPLS LDP binding, that is the LIB table, also you can see this LDP ID. Local binding is label 19 for example quad 3. Remote binding